Welcome to this new video on music analysis. This video will do a little bit of time windowed analysis of MIDI files. So let's get started. We need the tidyverse library and the tabr library. We need a few data files to work with, so let me load them in. This first file is downloaded from the internet. It is a MIDI file that is a rendition of Bach's Prelude and Fugue 846. The second and third MIDIs that I will load are files that were recorded at our house on our electronic piano. This first one was additionally passed through an online MIDI converter, which sort of changes the structure of the MIDI file a little bit. And this other one was recorded directly off the instrument. Okay, now that all the files are in, let's combine all the songs into one data frame. I'm going to add a column for the name, which helps the analysis later, so we can run some analyses for each or all together, as might be something we want to do. If you're a little bit confused about what I'm up to here, have a look at the HW3B video in this playlist, where I explained it in a little more detail. But at this point, we're just setting the stage. Okay, so all the data are stacked, and now I'm going to pick out just the note on events. Because the note on events are the ones that carry around the notes that we need. And at least for the analysis we're doing, everything else is pretty much redundant. I'm going to add on from tabr, I'm going to use the asmusicdf function, which is going to supply us note frequencies, intervals, and various other useful pieces of metadata per note. And I'm also going to add in the note end times, which are the sum of each of the note times and their lengths. Oops, did that wrong. Because that's supposed to be not times, that's supposed to be time and length. Easily fixed. Okay. Now what I'd like to do is I'd like to split up each of the songs into 10 equal blocks by time. In order to do that, I need to know the length of each song. So let's make a little table, sort of a subtable that carries around the lengths. We'll group by name, because each song has a different length. And let's carry around the total time, which is going to be the largest of the end times. Songs notes. Oh, I spelled songs notes wrong in the previous command. There we go. Okay, now let's take a look at these songs' lengths so you can just see what they look like. There they are. The group by was important because it modifies the way that the max function in the summarize works, so that it's maxing over each of the different songs independently because they're the different groups. Okay, sounds pretty good. Well, we want to bring these total times back into the original data. If you look at the original song's notes table, you can see that it's got all of these different properties, including note frequency and whatnot, and times. we'd like to compare the end time versus the total time, so we need a new column that has the total times. Which total times? These total times. So how do we do that? Well, an inner join will do that rather nicely. And so there we go. Dropped in and updated this table. It now has a total time, and the total time is per song. Okay, great. So now what we're going to do is we're going to break up these note events based on their times. We want to split each song up into 10 equal blocks in time, and then pick out each of the notes that are in those separate blocks. This kind of analysis allows you to do a little bit of averaging and also manage the fact that the song can vary over time. It is helpful to keep the number of equal time blocks we're making a variable so that you can change it later and try the analysis several different ways. I encourage you to do that. For this particular analysis, I'll use 10, but certainly varying this greater or lesser will be kind of useful. Now, how do I split up by time? The way to do this is actually to add yet another column that carries around which time block the note corresponds to. So let's do it. Let's make a new table. That has, let's see here, that has just what we need. So we've got our song lengths already in there. So we need to add in mutate a time block variable. And what is that going to be? Well, the way to do this is if you think about the time, we're really interested in the fraction of time that has passed versus the whole amount of time. So it's really something like the time divided by the total time. And what the time blocks does is you want to scale that out to say that when I hit 100%, that should be time block number 10, or indexing starting at 0, 9. And then we round up or down. The floor function will round down for us. So this now tells us which notes are in which time block. So if we look at the time blocks version, you can see all of these notes are in time block 0, and then eventually they go up. There's the notes in time block 1, etc. You don't have to worry about grouping by song because that's already captured in the total time column. So that's already taken care of for us. We can now take a look at the different songs and see how many notes fall into each time block. This gives you an idea of tempo and chord structure a little bit. They're kind of mixed together. Handy to group by name because we have 3 different songs here. So let's just count the time blocks. If I go ahead and do this, it's not so convenient to read, but a pivot makes it into a nice human readable file, or human readable table rather. And you can see that there are 10 time blocks, 0 through 9. The Bach piece has a definite something happens at time block 6, whereas the 2 improvisational pieces don't really. In fact, that time block 6 is the beginning of the fugue part. This particular MIDI file is a prelude and fugue. So that's pretty neat. Well, you can go right ahead and say, well, let's take a look and see how they're structured. I think a little bit of a plot might be handy here. So we can take these guys, and rather than grouping by, so we don't need the pivot, in fact, we'll just sort of walk back to here and say, pick out the Bach piece, and let's make our notes kind of structured. Let's render it as a piano roll. The nice way to do this is with a geom line range. equals frequency. This will give us a bit of a piano roll, and you can definitely see that around the middle of the song, yeah, all right around this time switch here, the structure of the song changes rather dramatically, and that is indeed that fugue piece versus the prelude piece, as I suggested. Okay, well, it's also handy to plot this particular column. It's not highlighting very well, but okay, so let's do it. We've got our blocked data here. Let's plot the time block versus n, which came out of the counting. So let's get that counting going on here. Count of name, note, and time block. We'll get an idea of note usage. There's a lot going on in this particular plot. We've got the time block, which will stand in for the time. We have n as the number of notes that are in each time block. We're going to group by note and color by name. Okay, lots going on. And actually, the plot gets super busy if I run this. Kind of see this is kind of crazy. It's a little bit nicer if we do a faucet wrap so that it splits up a little bit. And let's faucet wrap by note. Oops. There you go. You can definitely see that one of the fugue things that happens in Bach is that he starts using the note A an awful lot more than the rest. So this gives you an idea of some things you can do. You can identify the fact that there's a transition in the piece of music by doing this time blocked analysis. Hope that was interesting.